As we've said before, moving electric charges create magnetic fields. This is how magnets work. Because electrons are moving within the magnet, a magnetic field is generated around it. So if magnetic fields are made by moving charges, then wouldn't wires themselves create magnetic fields around them? Well, the answer is yes. If you have a wire with current I, it produces a magnetic field around it according to this equation. Mu naught represents the magnetic permeability of space. This is a lot like epsilon naught, but for magnets. Now you can see that this decreases as a function of R, so the further out you are from the wire, the smaller the magnetic field will feel. So what direction does the magnetic field point? Say hello to a new kind of right-hand rule. Point your thumb in the direction of the current and curl your fingers around the wire. The way you curl your fingers is the direction of the magnetic field. So with this current going up, when I curled my fingers, the magnetic field would be coming out of the page on the left and going into the page on the right. You can actually combine this in all sorts of interesting ways. Let's say we put two wires next to each other with current going in opposite directions. Should these attract or should they repel? What if the current was going in the same direction? How about if we have current coming from going through a wire and we put a charge that's moving nearby? What will be the force on this charge from the magnetic field created by this wire? Using this relationship and your other Lorentz force relationships, you should be able to figure out all of these scenarios.